Hi class, let's take a look at example 3. And we're dealing with another confidence interval, and it's still for the standard deviation. Um, Let me just write down here that the degrees of freedom, it's actually going to be 11 for this one. And let's start with the critical values. So the critical values, we're going to be looking at the chi-square distribution. And in this case, we're looking at 11 degrees of freedom. So it is gonna have like the generic shape that shows up everywhere on the graph. So it's gonna be something along these lines. The values of C is equal to 99. So therefore alpha is equal to 0.01, and alpha divided by 2 is equal to 0.005. So we're going to have a chi-square value on the left here and another chi-square value on the right. Let me just shade the tails. So this portion is going to have 0.99. This is going to have 0.005, and this portion here will have 0.005. Remember that the total area under the distribution is 1. Next order of business is to find out the total area that these chi-square values are going to have to the right. So the one on the right, or x squared to the right, it's going to have a total of 0.005. The one on the left, in terms of total area, it's going to have the 0.99 plus the 0.005, which is going to give us a total of 0.995 for this particular one. So as we look at these values on the table, the first one's going to have 0.005 area to the right, and with 11 degrees of freedom. So that means we're looking at 11 degrees of freedom, 0.005, it's going to be the 26.757. Let me double check. 26.757. And then the one on the left, 0.995 area, it's going to be here. 0.995, 2.603. So this is going to be approximately 2.603. And let me double check. 995, 2.603, 005, 26.757. And let me pause the video here for a minute for everybody to catch up, to make sure that you're clear how to find those values on the table. Okay, let's actually do the last part, and this is the evaluation of the interval. So in this case, the 99% CI for, and we're using the standard deviation, in this case is sigma, it's going to be equal to the following. And then I'm just going to move on to the formula. So we're doing the standard deviation. So therefore, you could just go directly to that formula. So we're looking at the following. So our values of sigma are going to be bounded by the following. So this is going to be the square root. We have n minus 1 s squared, and then we have the chi-square value on the left, and then square root of n minus 1 s squared, and then the chi-square value on the right. We're going to be evaluating the values of n is equal to 12, the standard deviation given in the problem of 1.3, which is going to give us the following. So our values of sigma are going to be bounded by the square root, and this one's going to have the 11 times the 1.3 squared, and then we're going to use the one on the right, the one on the left, so 2.603, and then square root of 11 times 1.3 squared, and then the 26.757. Please take a second to evaluate those two so we can compare answers. So my lower limit, I'm just gonna round to 4 decimal places, 0.83, 35, rounding it to 4. The upper limit, I'm getting 2.67, 24. Also rounding to 4 decimal places. Please evaluate that to make sure that you're matching. And then the final step would be to express it as a sentence. So the 99% CI for sigma is 0.8335 to 2.6724, and we're dealing with seconds. This is supposed to be a 4. That's the unit that's given in the problem, and that's actually it. Same as we did before, I want to see the formula and then what values you're actually evaluating. Yep, 2.6724. That's actually it for this one.